Hi everyone, my name is Alex Tomsic. I'm the Director of Engineering for Red Wolf Reliability. This is the next video in our series on our Voyager FDS sensor. Today we're going to talk about the installation procedure for the sensor. For everyone watching, hopefully you've been able to see our other videos on our Voyager FDS sensor. If you haven't yet been able to see those videos, please go ahead and go to our website at voyagerdynamics.com, where you can watch all of the previous videos that discuss the Voyager FDS sensor. Specifically, this video today is going to talk about the installation procedure for the sensor, and it'll provide a background on how to appropriately install the sensor and some of the nuances that come with that. Before we discuss the sensor installation procedure, I quickly wanted to discuss the sensor labeling convention we use for sensors that are installed. In a previous video, we've discussed the sensor installation locations, where you would install sensors for different kinds of bearings that your machine may use, but we haven't specifically discussed that labeling convention in full detail. So the big thing is the sensors are labeled based on their installed position, and the labeling convention is defined based on the viewpoint of you standing at the back of the driver looking towards the driven machine. So we use two basic labeling conventions. First, the bottom dead center sensor sits below the shaft, directly below the shaft on a horizontally mounted machine. Then the other labeling convention we use is a label that's based on the angle the second sensor would be away from bottom dead center and the side that sensor is on relative to the center line of that bearing. So that's the right or left. For example, here in this figure on the right, we have two sensor locations. One is a 45 left, the other one is a 45 right. That right or left denotion does not rely on shaft rotation direction. Instead, it's based on the viewpoint of standing from the back of the driver looking towards the driven machine. So your sensor installation location depends, for the second sensor, depends on the direction of rotation of the shaft. For example, if we have a shaft that's rotating in the direction as shown in this figure, we would place the second sensor 45 degrees in the direction of rotation from bottom dead center. So we would place the sensor at the 45 right location. But the labeling convention is defined as what your right and left would be when standing at the back of the driver looking towards the driven asset. I just wanted to clarify that point to make sure it's clear where that comes from. Here we have the list of recommended materials for installing the Voyager FDS sensor. Of these materials, you'll need acetone, which is used to clean the surface of all oils and other residue, isopropyl alcohol, which is used to clean any residue from the acetone, nitrile gloves, since we're dealing with chemicals, as well as safety glasses just to protect your eyes. You're going to want some lint-free rags or gauze pads for final cleaning of the surface. You can also have some extra rags that don't necessarily need to be lint-free for heavier cleaning. You'll always follow that up with lint-free rags. You'll want sandpaper of various grits. We would recommend 60 grit to give the best surface finish. You'll want adhesive, which we use Permabond 820. That's the only adhesive that we would recommend for the Voyager FDS sensor. You want a magnetic application tool, which Red Wolf Reliability produces and sells as part of an installation kit with a bottle of Permabond 820. We have some various designs for these application tools depending on the area you're trying to install the sensor. You want an angle finder, either a digital angle finder or an analog angle finder, for positioning the sensor. It's useful to have a marker to mark the surface and a straight edge to ensure that the surface is flat. And then you'll want some sort of power tools, such as a grinder with a flap disc or an oscillating tool with an abrasive pad, in order to prep the surface in instances where hand sanding and chemical paint removal are not enough to prepare the surface for the sensor. For the purpose of this installation video, we have a section of flat steel bar that we've prepared with a painted section which is where we're going to actually install the FDS sensor. Now, before you do any heavy surface preparation, you should take a dry cloth and brush all dirt and debris and grease off of the surface to ensure you have a clean surface at the start of your installation. After removing all dirt, grease, and other debris from the surface using a dry cloth, you now need to remove all of the paint from the surface and get your prepared installation location down to a flat bare metal surface. In many instances, you can use a chemical paint removal method. Here I'm using acetone to remove any paint from the surface, but in many industrial environments, the paint is too durable for acetone alone to remove effectively. In that respect, you would have to use some abrasive method, such as using a power tool like an angle grinder or an oscillating tool, and using an abrasive pad to remove all paint from the surface and get down to a bare metal. If you are using any abrasive method, you need to be extremely careful that you are not damaging the surface and creating a surface that's no longer flat. A convex or a concave surface can cause pre-strain of the sensor once installed, which can affect its sensitivity. So here I've used acetone to remove the bulk of the paint from the location I want to install the sensor. I will now go in with some 60 grit sandpaper and remove the rest of the paint from that area where I want to install the sensor. It's best to use small circular motions when you're sanding so that you don't have deep striations, and use light pressure so that you can retain the flatness of the surface. Throughout your sanding procedure, it's always a good idea to use a dry cloth to again remove any dirt, debris from the surface that was pushed up by sanding, so that you're not reintroducing that same dirt and debris to the surface. It's also important to change out your section of sandpaper often, one, so you can more effectively sand the surface, but also it's beneficial to, again, not reintroduce any of the debris that you've already removed from the surface through sanding. So here you can see I have a new section of dry cloth that I'm just brushing along the surface to remove any of that debris that's sitting on the surface. Continue sanding until you have a flat, clear surface that's bare metal, and then again regularly brush that surface with a dry cloth to remove any remaining debris from the surface that you've created from the sanding process. When preparing the surface for the FDS sensor, an area of at least 1/2 inch by 3/4 of an inch must be prepared. While you're preparing the surface, it's useful to use a small ruler to check the surface area that's been cleared to ensure it falls within these margins. If you have the available space, it's not a bad idea to clear even more area than that to aid in the process of installing the sensor, as you won't be trying to clean such a small area before installing the sensor. Here we have an example of a well-prepared surface on a large industrial motor to show this kind of surface finish that you're trying to accomplish and the size of the prepared area that you're looking for. Once you have cleared an area of at least 1/2 inch by 3/4 inch on your surface where you're going to mount the sensor, it's important to follow up with a final pass with 60 grit hand sanding to effectively roughen the surface area and ensure that the surface is ready to accept the adhesive. Here you can see I'm using small circular motions to get an even finish after my hand sanding. After you have finished with sanding, it's recommended to then take a small straight edge and check the surface for flatness by pressing the straight edge against the surface in 2 perpendicular directions. As you can see here, I have a small flashlight sitting behind the ruler, and I'm looking for light gaps between the ruler and the surface that I've prepared. Here I have an example of an uneven surface where I'm using a straight edge to check the flatness of the surface, as was discussed in the previous slide. This serves as a good example of what a surface that is not prepared for an FDS sensor could look like. Now that we have prepared a flat, clear, bare metal surface for installing the Voyager FDS sensor, we're now prepared to install the magnetic application tool on the surface and mark a reference line to be used later when installing the sensor. A special note should be made that the magnetic application tool uses a strong neodymium magnet, and special care must be taken as this magnet can damage electronics and can pose a pinching hazard. Grabbing the magnetic application tool firmly between both hands by placing your index fingers below the tabs on each side of the tool, place the side of your hands on the work surface and roll your fingers down to gently set the tool directly down on the surface. You can adjust the placement of the magnetic application tool at this time, as we will then mark a line to be used as a reference when installing the sensor. You can see here I'm repositioning that magnetic application tool until it's in the position I need the sensor to be installed at. I'm then going to take a black marker and strike a line across the front edge of the application tool on the work surface, and then mark a perpendicular line at the center of the magnetic application tool to be used again as a reference when we install the sensor. For applications that require installing a sensor at an angle relative to gravity, an angle finder can be used to mark a line on the work surface at the appropriate angle that intersects the center of the shaft. You can see here I'm marking this line using an analog angle finder. The same method could be used for a digital angle finder. Here you can see that I placed the digital angle finder on the side of the magnetic application tool, and I could adjust the position and angle of that magnetic application tool appropriately based on the output of that angle finder. Now that we've prepared a flat bare metal surface and we have marked our reference lines on the surface to be used later when we install the sensor, we're now prepared to clean the surface. Surface preparation and cleaning are extremely important when installing the Voyager FDS sensor, as the sensor is bonded to the surface using an adhesive. Just as before, the first step in our cleaning process will be to use a dry rag and brush any loose debris from the surface. Once we've cleared all loose debris from the surface, we will then use acetone first to clean the surface. Using a new clean rag, add acetone to the rag, and you will draw the rag across the surface starting at your reference line back and away from the reference line so that you don't remove the reference line in the process. After each pass, it's good practice to then replace or change to a new clean section of your rag and apply acetone before wiping again, so you don't introduce debris and residue that you've already removed to the surface. You'll continue wiping until your initial rags are coming off clean even after passing over the surface with acetone. Here you can see I'm moving to a new section of my rag with each pass so that I don't introduce any debris back to the rag. Now that my rag has remained clean after wiping the surface, I will now move to a gauze pad and repeat this process using acetone again. The benefit of the gauze pad is it is sterile, but also the white coloring of the gauze pad helps to aid in visualizing when your surface is now clean, as the white pad will show dirt and debris much better than any other color. Again, you can see I'm changing to a new section of my gauze pad with each pass, so I don't reintroduce any residue to the surface that I've already removed. You'll continue following this process until the gauze pad comes off clean even after wiping. It will typically take many cycles of wiping in order to get the surface clean enough before moving on to the next step. But time spent here is a major benefit when you go to install the sensor, as it'll aid in the adhesive strength and durability over time. So here you can see that last gauze pad was clear. We're ready to move on to the next step of cleaning. Now that we've cleaned the surface with acetone, we're ready to move on to the next step of cleaning, which is to wipe the surface down with isopropyl alcohol. The purpose of the isopropyl alcohol is to remove any residue left over by the acetone. So here I'm applying isopropyl alcohol to a gauze pad, and just as we did with the acetone, we'll wipe the surface starting at our reference line and moving away in a single pass before moving to a new clean section of our gauze pad. Now that our gauze pad has remained clean even after wiping the surface, we're ready to move on to the next step. After we've cleaned the work surface using acetone and then isopropyl alcohol, we're now ready to insert the sensor into our magnetic application tool and clean it. Taking the front edge of the sensor, press it up against the rubber bumper in the magnetic application tool and press the back edge of the sensor firmly down to seat the sensor in the opening of the tool. Then, using a fresh gauze pad and isopropyl alcohol, we'll clean the bottom surface of the sensor. It's very important that you only use isopropyl alcohol on the bottom surface of the sensor and not acetone. Once the bottom surface of the sensor and the work surface have been effectively cleaned, let the isopropyl alcohol air dry before moving on to the next step. Now that the work surface and the bottom surface of the sensor have been effectively cleaned, we're ready to apply adhesive to the bottom surface of the sensor and prepare it for installation. Using Permabond 820, which can be purchased as part of the FDS 102 installation kit, along with a magnetic application tool from Red Wolf Reliability, you will apply a very small amount of adhesive to the bottom surface of the sensor. Do not apply directly out of the bottle, as it is very hard to control the adhesive quantity. Instead, it's recommended to use a small application tool, the tip of a small zip tie or a paper clip work well, and to apply 3 small dots equidistant along the midline of the sensor. It takes a very small quantity of adhesive to provide a large amount of strength to the sensor mounting. Too much adhesive can affect cure times and can reduce strength. If too much adhesive is applied to the sensor, simply wipe the sensor with a rag with isopropyl alcohol to remove any additional adhesive and then reattempt adding the adhesive to the surface. The image on the slide shows the amount of adhesive I just applied to the sensor. As you can see, it's a very small quantity of adhesive, but by splitting the adhesive into 3 separate dots along the length of the sensor, it helps in ensuring that the whole surface of the sensor becomes bonded. Again, it's not recommended to apply adhesive out of the bottle as it's too hard to control the quantity, and too much adhesive is just as bad as too little. Now that we have applied the appropriate amount of adhesive to the bottom of our sensor, we're now prepared to install the sensor to our work surface. Grabbing the magnetic application tool with the sensor installed, gently set the sensor down, lining the magnetic application tool up with our reference marks in one foul swoop, and do not move or rotate the sensor after it's been set down on the surface. Moving and rotating the sensor can pre-strain the sensor and affect the sensitivity of the sensor, as well as affect the strength of the adhesive bond. Once the sensor is installed, let the sensor sit with the magnetic application tool on top of it for at least 15 minutes to cure before removing the tool. After allowing at least 15 minutes for the adhesive to cure, it's now time to remove the magnetic application tool. Grasping the magnetic application tool firmly by the tabs on each side, pull the tool up and away from the sensor in one foul motion without applying any twisting motion to the sensor. Once the magnetic application tool is removed, it's recommended to strain relieve the cable close to the sensor to ensure it's undamaged by any other installation work nearby. In this example, I'm just going to use a small adhesive-backed zip tie pad to attach the FDS cable down to the work surface. As an additional check, it is also recommended to apply a small twisting motion to the sensor to ensure that it is effectively bonded to the work surface. Thank you very much for watching this video on the installation procedure of the Voyager FDS sensor. If you have any questions on the installation procedure, please feel free to reach out to us at Red Wolf Reliability, and we can answer any installation questions you may have. Additionally, if you haven't watched any of our previous videos, please go to the website voyagerdynamics.com to view any of the past videos in this series. The next video in this series will review collecting data from the Voyager FDS sensor using a portable vibration analyzer, and we'll actually use the sensor that we installed in this video as our example. All right, thanks so much. Bye.